Okay, math lesson 3, question 5. A rectangular reservoir is 140 feet long by 60 feet wide by 25 feet deep. If the inlet pipe flows at 545 gallons per minute, how many days will it take to fill the reservoir? So let's draw our reservoir. Rectangular. Okay, this would be 140 feet by 60 feet by 25 feet. We're going to get the volume in gallons, then we can convert it to gallons per minute and then figure out how many days it's going to take. So 140 times 60 feet times 25 feet. That's going to give me the answer in cubic feet, the volume. But we need to get it to gallons. So we're going to convert that by multiplying it by 7.48 gallons per cubic foot. Okay, so when I do the math, my feet will cancel, leaving me with gallons. So that will give me 1,570,800 gallons. Now, if the water is going in at 545 gallons per minute, I'm going to divide this by 545 gallons per minute. Now, when I do that, my gallons will cancel, leaving me with minutes. Okay? So that leaves me with 2,882.20 minutes. Okay, but we need to know how many days will it take. If you remember from question 1, we know that there are 1,440 minutes in a day, right? Because we have 60 minutes in an hour times 24 hours in a day gives me 1,440. Okay, so what I'd have to do to determine how many days this is going to take, I will divide this number by 1,440. And that is going to give me approximately 2 days. And that would be A. The answer is A, 2 days. Okay. On to question 6. Question 6 is determine the rate of flow in a 24-inch pipeline flowing at full velocity of 6 feet per second. Give the answer in cubic feet per second. Okay, this is where we're going to start using the formula Q equals A times V, where the quantity equals the area times the velocity. The quantity is the flow, and it's expressed in cubic feet per second. The area is typically expressed in feet squared, and the volume is typically the velocity, the velocity is typically expressed as feet per second or feet per second. Either one of those would work. Okay, so if we go back to our question, the question says determine the rate of flow in a 24-inch pipeline flowing full at a velocity of 6 feet per second. Give the answer in cubic feet per second. Okay, so, well, let's see. Let's fill in the parts that we know. I think we're trying to solve for Q. So, we know the area. We have a 24-inch pipeline. To determine the area, it's almost like determining the volume, except you don't multiply it times the length. You only are measuring this flat slice of this. You're not measuring the full volume of the pipe, just this one slice here. So in order to do that, we can use the same formula, right? 0.785. To convert this to feet, so we know that 24 inches equal 2 feet. So times 2 feet times 2 feet. So 0.785 times 2 times 2 will give me the area. If I multiplied it by the length, that would give me the full volume. But this is only the area. So this number turns out to be, if I do the math, 3.14. We have foot times foot, so it's going to give me feet squared. Okay, so we know Q is equal to 3.14 feet squared, and then the problem gives us 6 feet per second. 6 feet per second. So if I multiply 3.14 times 6 feet per second, that will give me cubic feet per second, or the Q of the formula. So if I do the math, that comes out to 18.8 cubic feet per second. So again, you're just filling in the parts of the formula where you know the answers to determine what the cubic feet per second is. Okay? Okay, we'll try another one of these. The next question. Water is traveling at a rate of 2 feet per second through a rectangle channel that is 6 feet by 4 feet high. What is the rate in cubic feet per second? So again, Q equals A times V, cubic feet per second, feet squared, feet per second. Okay. So for this one, we know the feet per second is 2, and the feet squared we're going to have to figure out by figuring out the area of this rectangle. So our rectangle in this case is 6 feet by 4 feet. So if we do the math, 0.785 times 6 feet times, oh no, my mistake, it's a rectangle. So when we're looking at the volume, right, of a rectangular object, we multiply the length times the width times the depth. In this case, we're only looking at this front area, not how full it is, just the area of it. So we only have to multiply the length times the width. So 6 times 4 will give me the area. So that's 24 feet squared. Foot times foot will give me feet squared. So now we know that to plug this into the formula, we have 24 feet squared. So to solve for cubic feet per second, we will multiply 24 feet per second times 24 feet squared times 2 feet per second. That's going to give me 48 cubic feet per second. Awesome. Good job. Let's move along. We have one last problem. Water is moving through an 18-inch pipeline at a velocity of 5.5 feet per second. Calculate the quantity of water moving through the pipe. Okay, so we have an 18-inch pipeline, and we know that 18 inches is equal to 1.5 feet. Okay, just to set that up. So first of all, we know in Q equals A times V, we need to find the area. So that's 0.785 times 1.5 times 1.5. Again, that's the area of this area of the pipe. It's not the full volume because we're not multiplying it by the length. If we figure out that part, we know that this is equal to 1.77 feet squared, right? Because we have feet times feet, give me feet squared. Okay, and it says that it's moving at 5.5 feet per second, so we can do the formula. Q equals the area, 1.77 feet per second times feet squared, 1.77 feet squared times 5.5 feet per second. If I do the math, that comes out to 9.73 cubic feet per second. Okay, great job. That is the end of lesson 3.